All right, guys, here we go. We're starting chapter 3 of the review, the chapter 3 section of the review. We'll just do 3 questions at a time, starting with number 23. All right, here we go. Okay, number 23. Sketch the graphs of f of x equals 3 to the x and f of x equals 3 to the x minus 2 plus 1 on the same coordinate plane. Then state the domain and range of both functions. Pretty straightforward question, standard one. Something that you should definitely know how to do. Graph a basic exponential function with a simple base. And anything to the 0 power is always 1, right? So if I'm looking at this original f of x equals 3 to the x power, I'm always going to get this, unless there's a translation or some transformation, I'm always going to get that point, 0, comma 1. Let's do that point. Yeah, let's keep it black, actually. So 0, comma 1, right? And then, so just you can make a simple table and think 3 to the 1 would be 3, right? So at 1, you're at 3. 1, 2, 3. And at 2, you'd be at 3 squared, which is 9. So at 2, you're at 4, 5, 6, 7, 8, 9. You're over here. Meanwhile, if you go to the left at negative 1, that's 3 to the negative power, or 1 over 3 to the 1, which is 1/3. So you're over here in your fraction, and you're going to get closer and closer to this 0 asymptote, right? So then you can sketch this thing, asymptote right here at y equals to 0. And then it just grows really quickly after that. So that right there, that is my graph. Oh, that did not work well. Okay, let's just leave it there. Leave it there for now, crossing into the word, sorry. So that's the original f of x equals 3 to the x function. Now compare that to the second function, 3 to the x minus 2 plus 1. There's just 2 translations going on, right? You see this x minus 2 close to the, or the minus 2 is close to the x before it's attached to an exponential, right? So before the exponent happens, really, the minus 2 has already happened. That means it's a translation to the right, and in this case by 2. And then this plus 1, translation up by 2. Up by 1, I mean, sorry. So all you're going to do is take those same points I plotted and just move each of them 2 to the right and 1 up. Let's do that in purple. So 2 to the right and 1 up. This would be this original point. This guy here, 2 to the right, 1, 2, and 1 up. That puts him right here. Actually, no, it's not exactly, right? This is above that one, so it should be around here, actually. So your new asymptote moved 1 up, right? So original asymptote was right here at the origin. Now it's going to be 1 up here. That's where your asymptote is. I'm going to leave it as a highlighter. Let's draw other points. So this point here moves 2 to the right, 1, 2, and 1 up. It's over here. This guy over here moves 2 to the right and 1 up. 1, 2, and 1 up. Puts him right. 1, 2, 1 up. About there. Yeah. Then let's connect the dots with that same purple. Okay, so then this guy approaches that asymptote, something like that. Okay, so it's the same as the original function, except it's moved 2 to the right and 1 up. Now let's state the domain and range. So let's start with f of x first, equals to 3 to the x. The domain is everything, right? You can take any x value. And then the range, well, you never quite get to 0, but you go anywhere as high as you want, so 0 to infinity. Now for f of x equals to 3 to the x minus 2 plus 1, domain is remaining unchanged, because even though you move a little bit to the left or to the right, in this case right, then you're still going to go forever to the left and forever to the right, so that stays the same. But the range changes slightly. You moved everything up 1, so you can't quite hit 1. You can't hit anything below 1. So it goes from 1 to infinity. That's a open bracket here, circle, soft bracket. What do you call it? Parentheses. Because yeah, what do you call a soft bracket? Parentheses. Because you're not actually hitting that asymptote. Yeah. Okay, that was 23. Let's cross out 23 and just finish that one. And move on to 24. Sorry for the pause here, guys. I was meant to start a timer, but I forgot. We started now. Okay, so 24. Similar question, but this time you have a 1. You got a 1/3 on the inside instead. So you're gonna have the graph going the opposite way, where it's shrinking instead of growing. Simple, do the same thing. Anything to the 0 is still 1, so you're still getting that point right here is 0, 1. Yeah, I'm doing here f of x equals 1/3 to the x. 1/3 to the 1 power is 1/3, so it's down here. And 1/3 to the negative 1 power is 1/3. You flip it upside down, so you become 3 to the 1, which is 3. So you notice it's very similar to what I had in the last case, except it just kind of flipped. Yeah, it's flipped over the y-axis. If I put -2, that's 3 to the second power 9. 3, 4, 5, 6, 7, 8, 9. And so that's right here. Okay, and then I'll connect those dots. You notice that I have a horizontal asymptote right at 0. So it approaches 0, but never quite hits it. Just like that, nicely done. Okay, now f of x equals to 1/3 to the x plus 2 minus 4. Again, you got a translation. Here, this x plus 2 happens before the exponent is applied, so that's a shift, in this case, to the left by 2. And then minus 4 is a shift down by 4. So to start, what I'm going to do this time is I'm going to graph that horizontal asymptote, the new one. 1, 2, 3, 4. It's 4 down, yeah? So used to be at, use a highlighter. It used to be at 0, so now it's going to be at -4 right there. That's the horizontal asymptote. And then, yeah, let's shift all our points. So this point right here, it's going to move to the left by 2 and down by 4. So 1, 2, 1 or 2 here, and then down by 4 puts it at -3 right there. Okay, so this is my new starting position. This guy, same thing, right? It's going to go left by 2, down by 4. It's going to put it right here, right above the line -4. This guy over here, left by 2, puts it 1, 2, and then down by 4 puts it at -1 right there. This guy, left by 2, 1, 2, and then down by 4, 1, 2, 3, 4, right about here. Okay, I'm gonna connect those dots. So the shape is the exact same. It just shifted left and down. Okay, that's sketch. Now let's do the domains and ranges. Starting with f of x equals to 1/3. Oops, sorry. 1/3 to the x. The domain, again, is kind of similar to last time, right? -infinity to positive infinity. Everything's okay. You're going forever to the left and forever to the right. The range for the original, you don't go below 0. So kind of same as last time. It just happens in reverse, yeah, but it doesn't matter. It doesn't matter for the range. Still going as high as you want, still going down towards 0. And then 1/3 to the x plus 2 minus 4. Again, the domain unchanged. But the range should be down by 4. So it's going to go this time down towards -4, up towards infinity. -4 not included because you never quite hit that line. Okay. All right, that was 24. 24, 23, kind of similar questions. One of them grew, one of them didn't grow. I expect to have at least one or the other of those two. Maybe a question about like whether the function is growing or not growing, depending on if the base is a fraction or not. Or if the base is bigger than 1 and it's growing, right? If the base is smaller than 1, then it's shrinking, like we just saw. Okay, 25. Investment of $20,000 earns 10% annual interest. How much will this be worth after 30 years if interest is compounded monthly? Use the formula. It's given to you right here. A equals to P, 1 plus R over N to the NT. So pretty straightforward question. Let's make sure you're answering the right question though. It says, how much will this be worth? So in other words, how much is the future value, the A, right? That's what we're going to figure out. Easy, straightforward. That means you're just going to fill in the variables to the right. We need to know what those variables are. So to start with, my strong recommendation, and this is a very strong recommendation, just write the variables. So if you do this much, you're going to get at least half credit if you have it correct, if you have the correct variables. And even if you screw up what you're entering into the calculator, then you're still going to get half credit for this part at least. Okay, so how much did you put in? That's the P, right? That's the 20,000. This part, right? The rate is 10%. So as a decimal though, that's 0.1 or 0.10 if you prefer. If you put it as 10, the only reason to put it like that is to see the direct correlation between 10%. Yeah, see, it's 10 after the decimal place. But of course, it's the same as 0.1. N is the rate of compounding per year. So this is monthly in this case. This is your N. So N would be 12. And then for 30 years means this T is 30. Remember, T is always in terms of years for this compound interest formula. All right, so with those variables, you're just going to punch it into your calculator. Let me see if I can just open up into calculator. Oh, see the weird stuff my wife is watching. Okay, let's see. A equals to P. P is 20,000. I'm just trying to commit this to memory. 20,000, 0.1, 12, and 30. Okay. So 20,000 times 1 plus the rate is 0.1, that's R, over N. N was 12. Raised to the, so the power is this button here. That's A to the B for me. Sometimes it looks like a caret on your calculator, depending on the calculator, or X to the Y. Raised to the NT. So make sure your exponent is in its own set of parentheses. N is 12, T is 30. So N times T is 12 times 30. Okay, and you get 396,747.99 to the nearest cent. 396,747. 396,747.99 to the nearest cent. Yeah. 396,747.99. Yeah. Okay, we just round to the nearest cent. So there you go. Did you answer the question? Yeah, you answered the question. 25 done. Okay, how are we looking? I think we can do at least one more. Maybe even 2. Let's see, where were we? Okay, so we finished through 25. Let's see, 26, 27. Two more graphing questions. Let me think. I think let's do the next 2. Yeah, let's do the next 2. And then we'll cut this first video off. Yeah, I think we'll do either 2 or 3 videos for chapter 3. Maybe I think 3 makes sense. Okay, 26. Sketch the graphs of log base 3 of x and log base 3 of x minus 2 plus 1 on the same coordinate plane. Then state the domain and range for both functions. All right. For these, I like to make a little table. Last time I kind of did the table in my head because to me exponentials are so easy, but really I guess best practice is probably to actually write it out. And for logs, I think that's especially true. So let's write it out. Little table. Y is equal to, we'll start with log base 3 of x. Log base 3 of x. So just a reminder, what does this mean? This means that 3 to the y 3 to the y is equal to x, right? So for that reason, it's actually helpful to start with the y first. And say what happens when y is 0, then that would be 3 to the 0 is equal to 1. So x must have been 1. And as a check log base 3 of 1. 3 to the 0 would be 1. So if I put a 1 in there for x, then I would pop out a 0. And that makes sense. That's correct. So last time, when you're doing the exponential functions, you always got the point 0, 1, right? With logarithmic functions for the basic ones, you get the point 1, 0. So really you can think of it as, and this also makes sense because the logarithmics we know are the inverses of the exponentials, right? Which is just the reverse of x and y. So if you switch x and y in your exponential function, you're going to get the logarithmic function. So let's kind of do the same points, right? If I put 1 for y as the exponent, then that's going to be 3 for x. If I put 2 for y, then that's going to be 3 to the second, which would be 9. You can double check it like that. If I put a 9 in here, log base 3 of 9, then 3 to the second power is 9. Right? And then another nice point to check is -1. And then that would be a third, right? Because 3 to the -1 is a third. Okay, so I got a nice, 4 points, kind of the typical points. Sort of the same points I used last time, except just swapping x and y's, right? And so let's pull on. 3, 1 would be the next one. I should start with black because last time I started with black, yeah, for the first initial graph. 3, 1. And then, what is it? 9, 2, 2, 3, 4, 5, 6, 7, 8, 9, 2. Yeah, and then 1/3, -1. So 1/3, -1 is right about here and here. So now let's connect these dots. You notice that you have a vertical asymptote, right at x equal to 0. Sort of similar to how you had a horizontal asymptote at y equal to 0 for the inverse function, which is the exponential, right? That's who your asymptote is right there. Asymptote's right there. It never actually technically hits that asymptote. So let me draw it a little narrower. It never actually touches that. Okay, that's the original graph. That's log base 3 of x. So log base 3 of x minus 2 plus 1, same kind of deal as last time with the exponentials, right? This is a -2 close to the x. That's a shift to the right by 2. Plus 1 is a shift up by 1. So let's plot the new points in purple. Right 2 and up 1 for each point. So this one, right 2, up 1. That happens to land on this guy. Just so happens to land on that guy. This guy where it was, right 2, up 1, puts it right here. This guy, right 2, 1, 2, up 1, puts it right here. This guy right here, right 2, 1, 2, up 1, puts it right here. And then we had a vertical asymptote at 0 last time. That asymptote should have shifted 2 to the right. So now it should be over here instead. Yeah, and then let's connect our dots now. So not actually touching that, not actually touching that one, but getting close to it. And then like that. Oh, missed. Okay, so I use a highlighter for my asymptote. In reality, this is not really touching that asymptote because my highlighter is just too thick. So I just put it that way. I put it as a highlighter just so you could see it when it's on top of the axis. But really, maybe I should do that. Let's do it as a dotted line instead. It's easier to see. But don't choose purple. Let's choose green. Okay, see that? See, so it gets close, but never quite touches, yeah? And that happens forever. Okay, so there you go. There's the two graphs. Let's take care of the domains and ranges. You know, for the follow-up graph for this guy, I could have made a table of values if I wanted to as well. And basically you just shift all your numbers, right? Just increase your y values by 1 and your x values by 2. And then you'd have the new set of points that you wanted. Okay, let's look at log base 3 of x. The domain for that, that's the red graph, right? That doesn't quite hit 0, but then goes forever to the right. Meanwhile, the range is from negative infinity to plus infinity. And notice, guys, that this is the opposite of the exponential function, right? If you reverse these two things and you have the exponential function, that all makes sense, though, because these are inverse functions of each other. Okay, the other one is log base 3 of x minus 2 plus 1. Domain first is starting from 2 and moving on towards infinity, right? Because he started from this position and moved to the right, but never quite hitting 2. And then the range is everything. You're going as far down as you want and as far up as you want. So negative infinity plus infinity for the range. Okay, that was 26. All right, we'll do one more and then cut this video off, guys. Number 27. We got a log of 1/3 this time. Okay. No problems. No problems. Log base 1/3. So let's start the same way as last time. First of all, let's prepare our coordinate plane here. And then let's make our xy table. Y is equal to log base 1/3 of x. But remember, let's remind ourselves, what does this mean? This means 1/3 to the y is equal to x. So easy point as always. If I pick y to be 0, anything to the 0 is 1. So again, I get the point 1, 0. I'm going to just make it nice and wide there. 1, 0. What about if y is 1? If y is 1, then that's 1/3 to the 1 is 1/3. Okay, and if I continue on, if I say 2, I'm going to 1/3 to the second, it's going to be a 9th. So 9th is like a tiny fraction. You know, it's easier for me to draw nice whole numbers. So in general, except for this 1/3, I'm going to avoid those fractions. So how do I avoid them? What about negative 1? 1/3 to the negative 1 would be 3 to the 1, or 3. And what about negative 2? That would be 3 to the second, or 9, right? Because anytime we negative, it flips this guy upside down. So 1/3 becomes 3 when it's raised to a negative power. And then raised to whatever number after that, right? So if it's negative 1, it's 3 to the 1. If it's negative 2, it's 3 to the 2. Okay, so I got a nice display of points. Let's plot them. 1, 0, I plotted already. And then 1/3, 1 would be right here, about here, yeah? Okay, what about 3, negative 1? That's 1, 2, 3, negative 1, right here. Oh, wait. Yeah. Okay, and then 9, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. Negative 1, 2 over here. Okay, so let's connect these dots now. Keep in mind, you have a vertical asymptote again right here at the center, right? Because exponential functions never going to hit 0 for x, because that's not a possibility. So invisible asymptote this time. Let's connect these dots. It goes there, bing, hits that number as always, and then oh man, missed. Because my hand was blocking the way, so it's hard to see where I'm going with that. There you go. Okay, so see it's decreasing this time, right? Whereas when log is, when the base is a number bigger than 1, it's increasing. But still the basic tenets are true. Your domain is going to be from 0 to infinity, range is from negative infinity to positive infinity. Okay, so now that I got all that, making myself some space here. Let's do the follow-up graph here. We're doing log base 1/3 of x plus 3 minus 1. Plus 3 means I shift 3 to the left. Minus 1 means shift 1 down, yeah? So 3 left, 1 down for each of the points. Let's go in order from left to right this time. So starting with that one, 3 left, 1, 2, 3, and 1 down, puts it right there. I was supposed to use purple because I've been using purple, yeah? 3 left, 1 down right there. Okay, this guy, 3 left, 1, 2, 3, 1 down, puts it right here. This guy moved there. This guy right here, oh, I'm sorry. You know, the first point is actually inaccurate. Sorry. Because this guy is actually not quite hitting this asymptote here. This is an asymptote here at -3, yeah? Asymptote started at 0, so now it's at -3. If you look at it closely at that guy, it's not on the line, it's slightly off the line. So it should be right about here actually. Here, sorry. Okay, this guy, 3 left, 1, 2, 3, and 1 down, puts it right there on the axis. And this guy, 3 left, 1, 2, 3, 1 down, 1, 2, 3, puts it about there. You're not connect the dots. Okay, my line drawing is not perfect. I know this looks like a vertical line. It's not exactly a vertical line. It's getting closer to the left edge as you go upwards. The same is true for this one over here. Okay, but that's a general picture. Now let's do our domains and ranges. Log base 1/3 of x. Domain. Okay, that's the one for in red, right? So you're starting from 0 and going to the right. Meanwhile, the range is everything. And then log base 1/3 of x plus 3. It got shifted to the left by 3, so the domain is from -3, not inclusive, to positive infinity. And then the range is everything. Negative infinity, positive infinity. Okay, so there you go, guys. We'll cut the video off here.